Let us do one question, okay? Let us do one question, and that will solve what you were trying to figure out. Okay, Mariam? Fine.
Yes, sir.
So the question is, calculate the pH of solution containing 3.7 into 10 to the power minus 3 molar hydronium ion. Okay, hydronium ion means H3O plus ions. H3O plus is hydronium ion. So they have directly asked the pH and they have given us the concentration. So the pH of a solution, it is equal to how much? pH it is equal to minus log of the concentration of H3O plus, or we can just write H plus ions. Okay, any problem till here, guys?
No, sir.
No, sir.
No problem, right? Now you guys tell me, what is the concentration of H plus ion given? What is the concentration given in the question?
3.7 into 10 raised to negative 3.
3. Okay. So by using the product rule, I can write this is what. Okay. One more thing that I will do is I will keep this minus as it is, and whatever operation I am doing with the log, I will do this inside the bracket and I will keep this minus intact here. So I will be writing log of 3.7. Now I don't know how to. I don't know the. I only know from log 1 to 10. Yes or no?
Yes, sir.
Yes, sir.
Okay. So what we will have to do, we have to not write in decimal forms. We will write this in form of a whole number 37, and then this will be becoming 10 to the power minus 4. Okay. So this is the manipulation that you have to do because we don't know the log of 3.7. So what we have to do, we have to write in terms of whole number. Then we have to write in terms of multiples of the whole number. And after the multiples of the whole number, we can use the product rule. We can use the product rule. Now, I can write this as minus log of 37 plus log of 10 to the power minus 4. Yes, guys, yes or no? Tell me.
Yes, sir.
I hope till here all of you can do. Now you will be stuck and you will be asking what is the, I cannot I cannot write 37. It does not have any multiple, right? It is a prime number, I guess. It is a prime number. Yeah. So 37 cannot be divided into further multiples. So I will use a trend that I can see from log 1 to 10. So you see here log 1 to 10, yes or no? Can you see?
Yes, sir.
Now you see the differences, okay? And now you see the differences. What is the difference between log of 0 to 0.3? The difference is 0.3, yes or no? Then the difference is how much? 0.18, correct?
Yes, sir.
And from 0.3 to 0.48. If I look at the difference between 0.48 and 0.62, this difference is how much? 0.12, correct?
Yes, sir.
Yes. Then this difference is how much? 0.08, right?
Yes, sir.
And after that, this difference is how much? 0.6, 0.6. And here also you can say 0.6 or 0.5, right? 0.5, and here also it is 0.5. So I can see that if I successively, the value of log of whole numbers, they start to decrease, they tend to decrease. Yes or no?
Yes, sir.
Okay. So by using this trend, I will. So whenever you get a prime number now, if you have a large prime number, should be approximated to the next number What do I mean? So rather than calculating log of 37, I will calculate the log of 38. And it will be very comparable to log of 37. Okay. Now you trust me with this. You trust me. You have seen the trend that it will become successively. The difference is starting to decrease. That means log of 37 and log of 38 will not have a very huge difference. Okay. So just trust me on this. Then we will calculate. Then we can do what we can do. We can calculate log of 37 and then compare with that. Okay. So I will write this as log of 38. And this 10 to the power minus 4, the 4 will come 4 will come ahead and will become minus 4 log of 10. Okay, minus 4 log of 10 from the exponent rule, from the power rule, right? And you also know log of 10, it is equal to 1. Log of 10 is equal to how much? It is equal to 1. And then you can write again minus log of 38. How will you write log of 38? You will write log of 38 as log of 19 into 2. Yes or no? Minus 4. Correct, guys?
Yes.
Now again, you tell me, do I know the log of 19? No, no, I don't know the log of 19. Now, this is something that approximations, how the approximations work. So since you have initially what you did, you increase the number. Now what you can do? Now you can decrease the number to counterbalance it. Don't increase this once more. Okay, don't increase this once more. So what you can do, you can write it as. But for the first time, you have to increase. If you have to approximate only one time, then you need to increase it. Okay, then you need to increase it. Now what you can do, you can decrease the number and you can write here as 18. Okay, so this you can write as 18 plus log of 2 minus 4, right? Rather than writing 19, I have written 18. And this you can write as minus of log of 18 will be 9 into 2 and plus log of 2 minus 4. This will be equal to minus of log of 9 plus log of 2 plus log of 2 minus 4. So log of 9 was 0.96 or 95, right? So let me write 95 only. Plus log 2 is 0.3 plus 0.3 minus 4. So this will be equal to how much? Tell me, guys. Calculate this and tell me. This will be equal to minus of.
Sir, I rounded it to log 20. Is that okay?
You rounded it up to log 20. वही हम बोल रहे थे ना, like since you have increased here 37 to 38, you need to decrease here. Okay.
Okay.
Achha, we will see now. No problem. You have rounded it up to 20. We will see if the values are not very. The difference is not very large. Then you can take 20 also. But it is better to take 19 like this. Okay. Like in my experience, if you increase round up in one of the cases, then you have to round down in the next case if you are approximating successively. Okay. So you tell me first of all of you calculate this and tell me now what is the value?
Negative 2.45.
Negative of 2.45. This will be equal to how much? 2.45, right? Yes or no? Okay. So now what we can do, we can use the calculator and somebody calculate what is the minus log of 3.7 into 10 to the power. How much was that? Minus 4, minus 3. 3.7 into 10 to the power minus 3. So this is equal to 10 to the power, sorry, not 10 to the power. So if I use the calculator, minus log of 3.7 into 10 to the power minus 3, this is equal to 2.43. 2.43. Okay. So as you can see, the difference is not much, right? And how much did you get, Atif? What was your
Sir, I
value?
used log 20 and I got 2.24.
2.24.
Yes.
Okay. So as you can see, like, so it is kind of 2.4. I don't know. It will depend on the teacher. Okay, it will depend on the teacher. Most teacher, they should give marks here because again, you don't have a log table and you are just memorized. You have memorized some values and you are writing it down. But use this method, okay? The first approximation should always be rounding up. So you guys write this down, and I hope it has cleared your doubt also, Mariam. Yes or no?
Yes, sir.
So for 6.3, first of all, you will convert it to 64, okay? And then you will proceed on.
Done, sir.
Then all of you.
Done, sir.
Done, sir.
Done, sir.
Right, next. pH of a sample was found to be 6.4. By the way, 6.4 is the pH of human saliva. Calculate the concentration of H3O plus ions and OH negative ions. Okay. So how are we going to solve this? It is again, you have to take your anti-log, but it is again easy only. Okay, don't worry about this. So you have pH, it is equal to 6.4. pH means minus log of concentration of H plus, it is equal to 6.4. That means I can write this as log of H plus is equal to minus 6.4. Then I know that this is base 10. So 10 to the power of minus 64 will give me H plus ions. That means H plus ions is equal to 10 to the power of minus 6.4. Yes or no, guys? Tell me.
Yes.
Now, I hope you have seen in the previous lecture what we did. We wrote the difference. We wrote this exponent now. So you have to write the exponent, whatever the exponent is, the negative exponent, as the difference using, right? The negative power as the difference using the next number. That means I have to write minus 6.4 as something minus 7. That means the next number is 7 now. So we have to express 6.4 in a way x minus 7. So what will be x here? What will be x? I can write this as 0.6 minus 7 now. This will be equal to minus 6.4. Yes or no?
Yes.
Yes, sir.
Yes, sir.
So this is how you have to first of all represent it. And then you can write the concentration of H plus ion will be equal to 10 to the power of minus 6.4. Rather than minus 6.4, we will write 0.6 minus 7. And this will be in terms of molar. Okay, this will be molar concentration. Now you can write this as 10 to the power 0.6 into 10 to the power of minus 7. 10 to the power minus 7 molar. And we know that log of 10. So 10 to the power 0.6 should equal to x. So log of what is equal to 0.6, guys? Log of what is 0.6?
Log 4.
Log of 4.
Log of 4, na? So x is equal to how much? So 10 to the power 6 will be equal to 4, right? So 4 into 10 to the power minus 7 molar. Easy, yes or no?
Yes, sir.
Right. Now what we have to find? We have to find the concentration of OH negative ions. So whenever you have to find concentration of OH negative ions, we know that H plus ions into OH negative ions, it is equal to how much, guys? Tell me. H plus into OH negative will be equal to how much? Sorry, what happened? This is KW, na? 10 to the power minus 14. Oh, what happened, guys? Please remember this. Oh, I am not getting any answer. You guys don't remember this?
Yes, sir.
Okay, so please remember this is the equation that will going to help you in calculating OH negative if you have the concentration of H plus, and if you have the concentration of OH negative, it will help you to calculate the concentration of OH negative. So OH negative will be equal to 10 to the power of minus 14 divided by what is the concentration of H plus? It is 4 into 10 to the power of minus 7. So this will be equal to 1 by 4 into 10 to the power of 14 minus 7. 14, 7. This will be minus 7, right? Minus 7, which will be equal to 0.25 into 10 to the power of minus 7 molar. You can write this as 2.5 into 10 to the power minus 8 molar. Okay, so write this down. Let me know if you're done.
Done, sir.
Done, sir.
Done? Okay. Right, next. Calculate the calculate the pH of solution containing. Calculate the pH of a solution containing 0.3 grams of CaOH whole twice containing CaOH whole twice in 500 ml solution. Okay, in 500 ml solution. So see, in this question, so long question. So please see. First of all, let us try to solve it and then we will calculate. Okay. So first, what you need to do, you need to solve it mentally. You need to solve it mentally without plugging in any numbers. So we'll see what is given. So given to me is, first of all, mass of CaOH whole twice. And this is what? This is the mass of base, right? And we have been also given the volume of solution. Yes or no, guys? Tell me.
Yes, sir.
Okay. Now, you tell me, what can I get from mass? If I have the mass, what can we get?
So number of moles.
Number of moles we can get. So number of moles is also given. Okay, if I have number of moles and if I have volume, then what I can get from these two things?
Concentration.
Molarity.
Molar concentration, molarity. So always try to get to molarity. How are you going to get the molarity? Okay, yeah, I mean, in the question you have to look at that, because whenever you have got the to calculate the pH of the solution, it has to do something with the concentration. Okay, something with the concentration. Now let us see. We have got molarity of what? Molarity of base, right? We have got molarity of base. Now pH is what? It is the minus log of the concentration of H plus ions. Okay, now if you have the molarity of base, I can get the concentration of OH negative. That is true. Okay, I will write the reaction, and according to the reaction, I can get the concentration of OH negative, but I cannot get the concentration of H positive. So how I will write the concentration of H positive? Again, the Kw will help you. H plus concentration will be equal to 10 to the power minus 14 divided by the concentration of OH negative, whatever you have, and that you will be getting by the molarity of base. Yes or no? You
Yes, sir.
understood
Yes.
this? You have got all the links? Yes or no?
Yes, sir.
So please, whenever you start this type of question, so initially what you have to do, you will first of all figure out how are you going to calculate, what are the formulas that you are going to use. Now, some points there that are always present, and in this case, that is the molarity. Okay. So whether you have acid or base, you try to figure out how to calculate the molarity, and the molarity will be the link. See, from molarity, you are going to molarity. How will you get molarity? You will get the molarity from mass. You will get the molarity from the number of moles, right? You will get the molarity if you have been given some, let us say, mole fraction or something. If volume is also given. So from all these, you will get the molarity. Okay. And from molarity, what you can find, if you have the concentration, that is molarity. And from molarity, you can find Kc. And Kc and Kp are also related. So you can find Kp also. What else you can find? You can find the concentration of H plus ions. And you also have the Kw. With Kw, you can find the concentration of OH negative ions, right? So many things. And also you can find the pH, right? You can also find the pH. Now, let us try to do this question. 0.3 grams and 500 ml. So number of moles will be equal to 0.3 grams and CaOH whole twice. It has 40 and OH is how much? OH is 17, right? OH higher, 16 plus 1, 17. 17 to the 34 plus 40, 74 grams per mole. 74 grams per mole. This is the molarity. This is the number of moles. What will be the molarity? The concentration of CaOH whole twice will be the molarity, that is 0.3 divided by 74 moles divided by 500 ml of solution. That means 0.5 liters. You can write this as 0.3 divided by 74 into 1 by 2. Yes or no? This will be moles
Yes.
per liter. Now you guys calculate this and tell me what is the answer. What is the molarity of CaOH whole twice?
Sir, 0.008.
Correct. 0.008 molars. Okay, 0.008 molars. Now we have to calculate the concentration of OH negative. Okay, we don't have to we don't have to end here. We have to calculate the concentration of OH negative. For that, you have to write the reaction. So CaOH whole twice. You have to see how much OH negative ion it is given. So as you can see, it will give 2 OH negative ions for each mole of calcium hydroxide plus Ca2 positive. Plus Ca2 positive. Now, from stoichiometry, you can see. From stoichiometry, that the concentration of OH negative is equal to twice the concentration of calcium hydroxide. And hence this will be equal to 2 times 0.008 molar, right? Which will be equal to 0.016 molar. Yes or no? that you can write as 1.6 into 10 to the power minus 2. Now also you can write the concentration of H plus, which will be equal to 10 to the power minus 14 divided by the concentration of OH negative, which is equal to, I can write 16 into 10 to the power minus 3, which will be equal to 1 upon 16 into 10 to the power of minus 11. So 1 upon 16, right? 1 upon 16 means 1 upon 4 into 1 upon 4. 1 upon 4 means 0.25. So 0.25 into 0.25, 625, 0.0625. 625 into 10 to the power minus 11 molar. And then you can write this as 6.25 into 10 to the power of minus 13 molar. This is the concentration of H plus ion. Then again, you have to not stop here. You have to calculate the pH. So pH is equal to minus log of the concentration of H plus ions, which will be equal to minus the log of, I can write minus 6.25 rather than writing minus 6.25. I will be writing 625 into 10 to the power of minus 15 molar. Okay, minus 15. So this is the log that I have to calculate. This is the log that I have to calculate. So don't worry about 625. Okay, don't worry about 625. It may see, wait a second, let me reshare this thing. It has been stuck. Okay, now all of you know that I can write 625 as how much? Log of 25 square, right? Plus log of 10 to the power minus 15. Yes or no? Tell me, guys.
Yes,
Yes.
sir.
Yes.
Okay, now again, you see here, minus log of, what is 25? 25 is nothing but 5 square, whole square. And here you can write minus 15, because 15 will come here and log 10 is equal to 1. Log 10 is equal to 1. That is why log of 10 to the power minus 15 will be equal to minus 15. I don't need to explain this, right?
Yes, sir.
No need, no? Okay, fine. Now you can write this as minus of log of 5 to the power of how much? Tell me. 5 to the power of
4.
4. Very good. Minus 15, and this will be equal to minus of 4 will come here into log 5. What is log 5? 0.7, no? Log 5 is 0.7. 7 4s are 28, so 2.8 minus 15, which will be equal to minus of 12.2, right? Minus of minus 12.2. This is minus outside the bracket, and there is minus inside the bracket. This will be equal to 12.2. Sorry, not 12.5, 12.2. So this is the pH. Okay. So see, patience is the only thing. Questions are long in equilibrium, but one thing is for sure, they won't have very, what I can say, they won't have very lengthy calculations. Will not be lengthy. Okay, so you'll not be calculating three digits number here in ionic equilibrium as you are doing in the chemical equilibrium, no, that you have to calculate the quadratic equation and all. You won't have to do those things here. So whenever you have the equilibrium question in your examination, first of all, you would do those questions in the examination. That is theory. Okay, that means you just have to write things down. You don't have to solve things down. You have to write things down that you remember very well. And when you are going to do the calculation part, that you do always at the end, because you can get stuck in calculation and that is going to eat up the time. And if it is going to eat up the time, then means you will not be able to write the other questions also. So write this down. Let me know if you're done.
Done, sir.
Is there anyone who is still writing?
No, sir.
No, all of you written? Yes or no?
Yes.
Okay. So in the last class, we have studied everything about the water. Okay, because water is our system and we have to add acid to the water, we have to add base to the water. That is why we first of all studied what is the condition of water, and we saw one property that is of utmost important, that the concentration of H plus ions into the concentration of OH negative ions. It doesn't matter whether we are adding H plus or OH negative. The product of the concentration of H plus and OH negative, it is going to be constant, that is 10 to the power of minus 14 at 25 degrees Celsius. The temperature is very important. The temperature is very important. Okay. Next thing that we saw as pH. Okay. Now I have not written anything about the pH, that if you have pH less than 7, then it is acidic. If you have more than 7, it will be basic, because I think you guys know this. Yes or no? You know now.
Yes, sir.
What, all of you? What about strong acid and strong base? Tell me, guys, the pH range for strong acid and strong base. No idea. Okay.
7, sir.
7 क्या 7? 7 तो neutral होता है. 7 is neutral. Okay. अच्छा, so let me write here. In the pH scale you have, so in the pH scale it will start from 1, 2, 3, 4, 5. Achha, wait a second. Let me not write. Let me just give you a photo here. Okay, so remember this. So 1 to 2 and 2.5, it is generally said to be strong acid, and you can say 1 to 2, pH 1, and if the pH is lying between 1 and 2, it is strong. If it will be 6.5, then it is weak acid, and these pHs are known as neutral. Then you'll have this as weak alkali, and after that you will be having that as strong alkali. Okay, strong alkali means strong base. Write this down. Let me know if you're done.
Done, sir.
All of you? Okay. Right, next, addition of acid in water. Okay. Okay, so when we add acid in water, we can write an equation that HA plus H2O is going to give me H3O plus ions plus, okay, H3O plus will be in aqueous. This will be liquid. It's going to be aqueous plus A negative aqueous. So for this chemical reaction, we can write an equilibrium constant. The law of chemical equilibrium says that it will be, the equilibrium constant will be equal to the concentration of H3O positive, concentration of A negative, divided by the concentration of HA into the concentration of H2O liquid. And since we know that H2O liquid, the concentration is equal to a constant, hence we can write that and multiply that to the equilibrium constant, and this will be equal to the concentration of H3O positive to the concentration of A negative divided by the concentration of HA. That is the acid. Okay, that means above you have the dissociated acid and below you have the undissociated acid. Okay, so K into H2O, both of these are constant, and this will give you another constant which we call as Ka. This is equal to the concentration of H3O positive, A negative, divided by the undissociated acid, that is HA. Now this Ka, it is known as the dissociation constant. What is Ka? Ka is the dissociation or ionization constant of acid. Dissociation constant of acid. Dissociation constant or the ionization constant. Now, if I have a strong acid, then obviously the H3O plus concentration will be high because most of the acid will be getting dissociated. It will be getting dissociated and it will be liberating H plus ions and A negative ions, H plus ions and A negative ion. And if the H plus ions and A negative ions will be higher and the undissociated acid will be very low in quantity, that means most of the acid is getting dissociated. It means that the Ka will be high. The Ka will be high. So strong acids, or I can write Ka is high, then acid is a strong acid. It is a strong acid. Okay, that means strength of acid is directly proportional to the dissociation constant of an acid. So write this down. Let me know if you're done.
Done, sir.
Okay. Related to Ka, there is another term which is known as the pKa. Okay, and pKa, it is defined as the negative log of the value of Ka. Negative log of the value of Ka. Now, I hope you can see that if I increase if the Ka is high, the pKa will be low. Can all of you see that?
Yes, sir.
If Ka is high, pKa would be low. pKa would be low. That means I can say higher the value of pKa, lower the value of Ka, and weaker is the acid. And weaker is the acid. So the relationship between the strength of acid and pKa would be the strength of acid. Strength of acid is inversely proportional to the pKa. So a strong acid has a lower value of pKa, and the weak acid has higher value of pKa.
Sir, what is P here?
The same thing, na? Minus log. It is defined as the minus log of Ka. P, na? You are asking P.
Yes, sir.
Okay. P again, the same way we had pH, na? Okay, so P is defined as the minus log of something. So if you have pH, it is the minus log of the concentration of H. If you have pKa, it is a mathematical function, you can say, as sine, as cos. You can say P represents minus log.
Sir, can you scroll up? I had some net problems.
Okay, sure. Till here?
Yes, sir.
Okay. Achha, I hope I told you guys now why do we have these terms pH and why do we have pH? Or no? Nahin. Okay.
Okay, sir. Took a screenshot, so thank you.
Okay. So all of you know that pH represents, what does pH represent? The concentration of H plus, yes or no?
Yes, sir.
Okay. Now, as you have seen earlier, I said now the pH of human saliva is 6.4, right? We also did a question on that. You can see here. We did a question. Where was that question? Yeah, 6.4. Fine. Now think about telling a common person that the pH is equal to how much? It is equal to 6.4. And you have been given an easy range that pH will range from 1 to 40. If it is less than 7, then it is going to be acidic. If it is more than 7, it is going to be a basic alkali. And if it is 1 or 2, between 1 and 2, it will be a very strong acid. If it is 13, 14, it will be a very strong base. Okay, so we have told these things, and common person can easily understand these things. But imagine telling a common person that the concentration of H plus was found to be 4 into 10 to the power minus 7. Does it give any idea about the acidity or the basicity of a particular sample or solution? Tell me. This number, what is more easy to understand, this number or the pH 6.4? Which is more easy to comprehend? 6.4, right? So please, so pH, scientists, they have introduced pH only to make things easy for common men, okay? That is the reason of pH and pK. And also it is easy to keep a track of these things, 6.4 and all. And also again, pKa, it is again, now pKa will be used mostly by chemists only, and also not only chemists, but different scientists of different field. If you are in organic chemistry, you will be, if you see some scientists now, if they are in organic chemistry, then you're also contributing it towards biology, okay, towards biology. So biologists also, they will be using pKa values, and because they have to determine the, I don't know, have you studied biomolecules till now in biology?
Yes, sir.
So there is one thing which is known as protonation states of amino acid. Have you studied about that, protonation state? No? You have not studied about protonation state?
No, sir.
No? Okay. Acha, for in some, you have not learned about the pKa of different amino acids in biology? No.
No, sir.
No, acha, fine. You will learn that in 12th standard, okay? Then you will understand at what if the pH, what you will be comparing the pKa and the pH of the environment, okay? So if the pH is higher than pKa, then will the COOH, the carboxylic acid group of the amino acid, will be in the form of carboxylic acid or carboxylate ion. The NH3, that means the NH2 amine group, will be in the form of NH2 or it will be in the form of NH3 positive. Okay, so these things that you will be considering. Biology, we don't get to learn these things, no problem. Okay, fine. Strength of acid is directly proportional, sorry, it's inversely proportional to the pKa. Okay, now let us move on and let us try to see a reaction. So when we have a strong acid, that is HA, and if it completely dissociates, if it completely dissociates, and it will give me H plus ions and A negative ion, that means I don't have any problem. I can write this reaction and I can calculate the concentration of H plus and concentration of A negative, as we have done in the case for CaOH whole twice. And we can directly write the concentration of the acid, because it completely gets dissociated, that is equal to the concentration of H plus. But things get a little messy if I have a weak acid. So a weak acid will have an equilibrium between the dissociated acid and the undissociated acid, which will be like this, H plus A negative. Yes or no, guys? Any problem here?
No, sir.
No problem. Okay. Now I want to see, because I will have some initial concentration of the H acid. So let me write this as C. C is the initial concentration. H plus is 0 and A negative is also initially 0. Okay, A negative is also initially 0. Now, if HA is getting dissociated, then how many molecule and how easily a particular molecule is getting dissociated will be dependent only on the acid molecule. Yes or no? Because there is no other reactant. There is no other reactant, because if I have, let us say, A plus 2B is in equilibrium with D. In this case, how much D is getting formed? It is dependent on the reactivity of A and B. How these two things are reacting. Yes or no? But in this case, the acid is not dependent on any other entity because it is the sole reactant. And in this reaction, what is happening? This HA bond is getting broken. And how easily this HA bond gets broken will determine how strong an acid is. Because if this HA bond easily gets broken, that means this acid is a strong acid. And if it requires some energy and it is difficult to break this HA bond, that means we will say that it is a weak acid. It is not an acid. Yes or no? Now, one thing I want to make clear and establish that for an acid dissociation reaction in which an acid dissociates into H plus and A negative, in that case, only acid is the reactant and everything depends on the acid. There is no other reactant molecule which is interfering on the dissociation of acid. Is that clear to everyone? Yes or no?
Yes, sir.
Okay. Now, when an acid is only dissociating, then either all of the acid will dissociate. If I took C amount of acid, acid will be dissociated. Yes or no? This can happen. This can be one case. This can be a case, right?
Yes, sir.
Or half of acid will get dissociated, or 1/3 of acid will get dissociated, or 1/4 will get dissociated, or let us see whatever amount get dissociated, I can write that amount as the fraction of, I can write the change now. I can write whatever is getting reacted as the fraction of initial concentration. Yes or no, guys? Tell me.
Yes, sir.
Okay. Now this fraction is what? This fraction is dependent, and it is completely dependent and only dependent on the acid. It doesn't matter how much acid you are taking. If half of the acid is getting dissociated, then it doesn't matter if I am taking 1 mole or I am taking 100 mole. In both the cases, half of the acid will get dissociated. And hence I will write the change as, this is the initial and this is the change. I will be writing in this case the change as the concentration into the fraction that gets dissociated. Yes or no? The fraction that gets dissociated. If a particular acid has a tendency that half of its molecule can get easily dissociated, then I can write that the change will be the initial concentration divided by 2. And this fraction is known, and this fraction is denoted as alpha. This fraction of molecules that get dissociated is denoted as alpha, and hence the change will be minus of C alpha. All of you do you have any problem with this C alpha now? Tell me.
No, sir.
No, no. How are we writing it? Why C? Why C is there? Because it is a fraction of the initial concentration. What is the initial concentration? The change is the fraction of initial concentration. Some fraction from the initial concentration has been reacting. Now this initial concentration is C and the fraction is alpha, and hence the change will be minus C alpha. If C alpha is getting reacted, what will be the amount of H plus? How much H plus will be found? Tell me, guys. Plus C alpha, yes or no? Tell me.
Yes, sir.
Because let us say if you had 100 moles of acid, half of it got reacted. That means 50 moles got reacted, 50 moles got dissociated. And then obviously you will be getting 50 moles of H plus ions and 50 moles of A negative ions. So this will be also plus C alpha. And hence in equilibrium, I can write at equilibrium, this will be equal to C minus C alpha. And here it will be C alpha into C alpha. Okay, C alpha into C alpha. Now for this case, I can write the K will be equal to the concentration of H plus ions into the concentration of A negative ions divided by the concentration of undissociated acid. Now, if you see this particular equation that I have written, it is completely equal to the Ka, right? H plus into A negative divided by Ha. Hence, I can write this as, this is the Ka. This is the Ka. What is the concentration of H plus ions, guys? Tell me, what is the concentration of H plus ions at equilibrium? C alpha.
C alpha.
What is the concentration of A negative ions? C alpha.
C alpha.
Divided by C minus C alpha. Right? Now, I can write this equation as C square into alpha square divided by 1 minus C minus C alpha. I can write this as C into 1 minus alpha, taking the C common. Now I can eliminate this C and this C. This will be equal to C alpha square divided by 1 minus alpha. So Ka, it is equal to C alpha square divided by 1 minus alpha. So this is one more equation that you have to remember. This is the relationship between the Ka and alpha. Alpha is what? Degree of dissociation. Degree of dissociation. Okay, now for weak acids, in weak acids, what do they have? In weak acid, very less number of molecules get dissociated. Very less number of molecules get dissociated. Therefore, the alpha is very, very less than 1. Is very, very less than 1. And hence I can say that 1 minus alpha will be approximately equal to 1. Hence, for weak acid, I can write for weak acid, Ka will be equal to C into alpha square divided by 1. Hence, Ka is equal to C alpha square. And you can write alpha is equal to, the C will go below Ka divided by C, and for square you will write the root. So alpha will be equal to the root of Ka upon C, I write this down. Let me know if you're done. Let me know if I have to scroll out or scroll above or something.
Done, sir.
All of you done? Yes or no, guys? Done?
Done, sir.
Done. Okay, fine. Now let us write what is the degree of dissociation alpha. Degree of dissociation alpha. So right here. For reactions in which one mole, okay, 1 mole does not mean 1 mole is the initial concentration. It means according to stoichiometry. 1 mole according to stoichiometry. Okay. stoichiometry, in which 1 mole of reactant gets dissociated . 1 mole of reactant gets dissociated. The change can be written as the change can be written as the fraction of reactant molecule as the fraction of reactant molecule that gets dissociated. This fraction is aka degree of dissociation. Degree of dissociation, and represented by alpha. Now, in terms of mathematical definition, please remember this is not a formula for calculating degree of dissociation. Okay, alpha means number of molecules of electrolyte that dissociated divided by the total number of molecules of electrolyte. Okay, this is alpha. Let me know if you're done writing this.
Done, sir.
Right, next, addition of base in water. Addition of base in water. So in base you will have BOH plus H2O liquid, which will be in equilibrium with what? Tell me. What happened? Base will give B positive, right? Plus OH negative. Yes or no? Plus H2O.
Yes,
Right?
sir.
Yes. When it is added in H2, what is going to happen? So mainly you can write the reaction like this. Base is going to give you what? B positive aqueous plus OH negative aqueous, and hence the Kb will be equal to the concentration of OH negative into the concentration of B positive divided by the concentration of the undissociated base, the undissociated base. This is the Kb. Similarly, pKb will be what? pKb will be minus log of Kb. Okay. And what is Kb? Dissociation constant of base. Dissociation constant of base. And stronger the base, higher the value of Kb, and lower will be the value of pKb. Lower will be the value of pKb. Greater value of pKb means weak base. Okay. Similarly, for Kb also we can write the relationship between degree of dissociation and Kb. It will be the same thing because it is defined as electrolyte, the alpha. It will be again C alpha square divided by 1 minus alpha. Okay, divided by 1 minus alpha. Again, alpha here is the degree of dissociation of the base. And for weak bases, we can write alpha is what? Very, very smaller than 1. And hence we can write that Kb will be equal to C alpha square. And we can also write alpha will be equal to under root of Kb divided by the concentration. C is the concentration of the base. Okay, C is the concentration of the base. Write this down. Let me know if you're done.
Done, sir.
Okay. All of you done?
Done, sir.
Okay. Write a question. K of HF is given as 3.2 into 10 to the power minus 4. 3.2 into 10 to the power minus 4. Calculate the degree of dissociation. Calculate the degree of dissociation of HF. So what is the formula? Ka, it is equal to C alpha square upon degree of dissociation after the concentration of 0.02 molar solution. Concentration is given as 0.02. K 1 minus alpha, right? To 1 minus alpha. So you have got the concentration. You have also got the concentration. Also you have got. You have also got the Ka. You also got the Ka. Now you have to remember. See, this K is equal to what? 3.2 into 10 to the power minus 4. 10 to the power minus 4. It is what? It is less than 10 to the power of minus 3, right? And 10 to the power minus 3 is less. That means, see, we have got the reaction HF. It is in equilibrium with H positive plus F negative. Yes or no, guys? Tell me.
Yes, sir.
Okay. And what is the K here? K is given to be 3.2 into 10 to the power minus 4, right? That means K is what? Ka is, it is less than 10 to the power minus 3. Extent of reaction, equilibrium, second lesson, right? When we were determining the extent of reaction, whether the reaction will be towards product or towards reactant, or there will be both amounts. So as you can see here, that it is less than 10 to the power minus 3. Hence, it is a weak acid. That means not much H plus is there. It is a weak acid. Yes or no? Also, you can compare this. That means what I have written Ka. Na? Ka is what? Ka is the concentration of H plus divided by the concentration of F negative divided by the concentration of HF. So this is equal to 10 to the power minus 4, let us see. That means if I will write this down, then if you can reciprocate this, H plus F negative divided by HF, this is equal to 1 upon 10 to the power 4. Yes or no? This is the meaning of K. This is the meaning of Ka na, that we have got here. I'm
Yes,
ignoring
sir.
the 3.2 also. Now, can you see that for how much? 10,000 molecules of HF, I have got one molecule of H positive. Then I can say na, that it is a weak acid. Yes or no? Because most of the acid, it is in undissociated form. That means HF is not giving me H plus ion very easily. Yes or no, guys? Tell me.
Yes, sir.
And hence, if it is weak acid, then Ka will be equal to C alpha square. Ka will be equal to C alpha square. So calculate this and tell me what is the answer. You have got alpha will be equal to under root of Ka divided by C. Formula based question, easy, okay? Formula based easy question. Tell me what is the alpha, guys? Calculate and tell me. Yes or no? This will be answer. 10 to the power minus 1.5.
Yes.
Okay, so how will we solve this? 10 to the power minus 1.5 can be written as 0.5 minus 2. Yes or no? This will be equal to 4 into 10 to the power 0.5 into 10 to the power minus 2. Yes or no?
Yes, sir.
And 10 to the power minus 10 to the power 0.5, according to the log table, this will be equal to 3. And because log 3 is equal to 0.48, which is nearest to 0.5. Right? Into 10 to the power. It will be minus 2 only, no? So we'll get this as 12 into 10 to the power minus 2. So you will get alpha as equal to 0.12. Okay. Write this down. Let me know if you're done. Done, guys. Can I move?
Yes, sir.
So similar type of questions will be there. Okay, similar type of questions will be there. Okay, so we have got the concentration of H plus is not, we have not calculated alpha. No, we have calculated the alpha. So in this question, we can add some more thing. We can add, let us calculate the pH also. If I want to calculate the pH of the solution, how will you calculate the pH of the solution? Question is calculate pH of above solution. So what is pH? pH is equal to minus log of the concentration of H plus ions, right? H plus ions. But for weak acid, concentration of the acid is not equal to the concentration of H plus ion, because all the acid molecules, they don't dissociate to give you H plus ions. They don't dissociate to give you H plus ions. So how are we going to calculate this? So in this, you have to do, you have HF, which is in equilibrium with what is the concentration given, guys? What was the concentration given? 0.02 ना? अरे कोई बोल ही नहीं रहा है, बताइए. 0.02 molar, right? And the concentration of H and F is 0, 0. What is the change? The change will be the concentration 0.02 into alpha. What is alpha? 0.12, and this will be equal to also 0.02 into 0.12, and this will be also 0.02 into 0.12. So at equilibrium, so this is the concentration, this is the 0.02 minus, rather I should write it like this, 0.02 into 1 minus 0.12. The concentration of H plus is 0.02 into 0.12, right? So this is the concentration that we need. The concentration of H plus will be equal to C alpha. C is 0.02 into the alpha is 0.12. Calculate this, what will be 0.02 into 0.12? Yes, guys. 2.4 into 10 to the power minus 3 molar. Now pH will be equal to minus log of 24 into 10 to the power minus 4. This will be equal to minus of 24 is, how should we write 24? 6 fours are, है ना? 6
Yes,
fours are.
sir.
So log 6 plus log 4, 10 to the power minus 4, it will be equal to what? Minus 4. है ना? Because,
Yes, sir.
है ना? Now you can write this as minus of log 6. What is log 6?
0.8.
0.78 plus log 4 is 0.6 minus 4. Now you calculate the pH. Done, all of you?
Yes, sir.
Okay. Right, next. The pH of a 0.01 molar, 0.01 molar solution of an organic acid is 4.15. The pH is given as 4.15. Calculate. Number 1, concentration of anion. How are we going to solve for the concentration of anion? What does it mean by concentration of anion? First of all, we have to learn that. So listen here, don't write. Listen here, don't write. So concentration of anion, what does it mean? It means that if you have acid Ha, if you have an acid Ha, it is going to get dissociated into H plus it will give you A negative, plus it will give you A negative. So this is the anion, right? This is the anion, and it is asking the concentration of the anion. It is asking the concentration of the anion. Now, if you see indirectly what it is asking the concentration of H plus only, because the concentration of H plus will be equal to the concentration of anion. Yes or no, guys? Tell me. They are in equal
Yes.
ratio. They are in equal ratio. So what you have to calculate here? Here you have to calculate the concentration of H plus ion, right? So since you will write, since the concentration of H plus is equal to the concentration of A negative, you will find out the concentration of H plus ions. So pH is given as 4.15. So you will write minus log of H plus is equal to 4.15. So the concentration of H plus will be equal to 10 to the power of minus 4.15. Okay. I hope you guys can understand this now. 10 to the power of, so this minus will go there first. I am not writing all these steps. So whenever you have to calculate, you can directly write the concentration of H plus from pH to concentration. H plus concentration is 10 to the power minus pH. Okay. You can write this formula is equal to 10 to the power of minus pH. Okay. Now, how will we calculate? This will be equal to concentration of H plus will be equal to 10 to the power of how much? 15, 0.85 minus 5. Yes or no? Guys? Right?
Yes, sir.
So 10 to the power 0.85 into 10 to the power of minus 5 molar. So 10 to the power 0.85, tell me. What is the nearest log?
7.
Log of
7.
yeah 7.
7.
7 into 10 to the power minus 5 molar. So I hope you guys are now comfortable with this log value, right? If you know these 1 to 10. Yes or no?
Yes, sir.
Yes, sir.
So this is the concentration of H plus. And that is why this is also the concentration of the anion A negative. The anion A negative. Okay. Now in the same question we have for the same data, we have to calculate the ionization constant of the acid. Ionization constant. What is ionization constant? Ka. Okay. Ionization constant. How will you calculate Ka? Is equal to the concentration of H plus divided by the concentration of A negative divided by the concentration of the undissociated acid, right? So write this down, then we will understand how will we calculate this undissociated acid, because we know the concentration of H plus and A negative is with us. We have just now calculated this. Now we have to find the concentration of the undissociated acid. How are we going to calculate that? Write this down. Let me know if you're done.
Done.
Done, all of you?
Yes, sir.
Okay. Now see. We have the initial concentration as how much? We have HA in equilibrium with H plus plus A negative, right? So initial concentration is given now. Initial concentration is how much? 0.01 molar for HA, right? There is some change. There is some change happening. The equilibrium concentration, we don't know the equilibrium concentration here. What is the equilibrium concentration for H plus? The equilibrium concentration for H plus is how much? 7 into 10 power minus 5. And here it is also 7 into 10 to the power minus 5, right? That means the change here, whatever x and x was there, this will be 0.01 minus x. And you can see that x is equal to how much? 7 into 10 to the power minus 5. Yes or no? Can all of you see that?
Yes, sir.
Because the change is x, and the x we have just calculated, it is equal to 10 to the power minus 7 into 10 to the power minus 5. That's why the concentration of HA, that is the undissociated acid, will be equal to 0.01 minus 0.00007. 1, 2, 3, 4, 5. So this will be equal to how much? 0.
Sir, 0.00993.
0.00993. So this will be equal to 9.93 into 10 to the power 1, 2, 3. 10 to the power minus 3. No? Now you can calculate the Ka, which will be equal to 7 sevens of 49. H plus into A negative. 7 sevens of 49 into 10 to the power minus 5 into 10 to the power minus 5, 10 to the power minus 10 divided by 9.93 into 10 to the power minus 3. will be equal to 49 upon 9.93 into 10 to the power minus 7. Yes, guys. So you can approximate here. You can approximate and you can write that this 9.93 as you can write here as 10. Okay, you can write this as 10 and you can write, if you're increasing a bit of quantity here, you can also increase here. You can maybe write 49 or you can also write 5. Okay, you can write directly 5 here, 4.9 or 5, whatever you want. For me, if I was there, I have some idea with approximation. I think this will be more near to 5 because what I am doing, I'm increasing some quantity in the denominator. So I will increase some quantity in the numerator also. Okay, so I'm just writing 5 into 10 to the power minus 7. This is the Ka. Don't have to calculate much. Okay. You solve all the 73 problems of NCERT, like put in time. You calculate the whole thing, approximate a few things, tinker here and there, tweak some values here and there, and then you check the value in the calculator. So you will get an intuition for the approximations in calculations, and that will help you a lot while you are in the examination. Okay, so in the examination, first of all, you always tweak some values and write the approximated value as the answer. And after that, if you get time, then you calculate the real value. Obviously, if you have much time left, then you can directly calculate. But I did not have much time in the equilibrium when the equilibrium was there in 11th standard. Okay. So how was your midterm examination? Midterm means the half-yearly examinations. You had much time or you did not have time? I think in half-yearly you would have time because there was in use. Maybe you had some numerical. Yes, Mariam, you got enough time in first term?
Yes, sir. There was not many calculations.
As a theory questions were more.
Yeah.
Yes, sir. It was okay.
Okay. What about Reba?
Sir, same.
Same. Same. Atif, for you also same? Yes, Atif. Atif is not here or what? Okay. Done, guys?
Yes, sir.
Yes, sir.
Okay. Now you calculate the last part. That is the pKa. What will be the pKa for this? Now pKa is equal to minus log of Ka. Calculate this. Send the answer in the chat. Okay. Send the answer in chat. Actually, you are having connection problems. Okay. Okay. So after you are done with this now, and if you have any doubts, Acha, Reba, you said you had some doubt yesterday. You said no.
No, sir.
Sorry. No. Acha, sorry. You did not say you had any doubt. I'm sorry. Yes, Samira, yes. You calculate this and then let me know if you have any doubt from the previous classes or if you have any doubt from the problems that I gave you to do. Okay, Atif. Waiting for others' answers. Okay, Mariam. So I think those answers are right. Yes, Deepa. Okay, fine. All of you are getting the same answer. That is the correct answer. The answer is minus log of 5 into 10 to the power minus 7. So this will be minus log of 5 plus minus 7, because 10 to the power minus 7. If I do the log, that will be equal to, minus 7. So log 5 is equal to how much?
0.70.
0.70 minus 7 should be equal to minus of minus 6.3, should be equal to 6.3. Okay, it will be equal to 6.3. Okay, so write this down. I have not written. And if anyone has any doubt now, please tell me. Mariam, Reba, Atif, Aisha, Abhinav, Mohammed Sheikh, Omar. Anyone?
No, sir.
No doubt. So you have done all those questions that I gave the last class.
Yes, sir.
So you have done till how much are you done? Till 35 you are done? Till 35, and after that I gave you assignment in the next class. No?
So I did till 27.
We have done till 27. Okay. Okay. So you have to write homework for today that you will be showing me. You will be submitting on Monday. So, but please keep your notes with while you are doing these exercises. Okay. So NCERT exercises 7.41 to 7.62. Okay. Some of the questions we have done in the classwork. Okay. But you can try that again. There is no harm in doing those questions again. Okay. Chaliye. So in the next class, first of all, I will be taking, because again, there are 20 questions here. So at least you have to do at least 6 or 7 questions daily. Then you will be able to complete till Monday. I hope in physics and biology and maths, easy chapters are going on, right? What is going on in maths, guys? Does anyone have maths here? Anyone who has math here? No? No one has maths. Okay. So in biology, what is going on? Plant transportation, if I have heard it correctly. Transportations in plant. What is going on in biology?
Sir, photosynthesis.
Photosynthesis. Okay. That is a heavy chapter, or it is an easy chapter?
Kind of heavy. It's okay if you learn.
It's okay. Okay. And what about physics? Physics, you would be having the second book, which is not very heavy. What is going on in
Yes,
physics?
sir. Kinetic energy.
Kinetic energy. Kinetic energy? Is that a chapter's name?
Sir, something
Kinetic energy and thermodynamics both, sir.
Achha. Okay. So those are not very heavy chapters. I mean, till I think rigid body, I mean, those rotational motion, that is one chapter, which is, I think, which is the heaviest chapter, because in that you have all kind of things going on, from NLM to the angular motion and everything. So you can give more time to chemistry now. On Friday, you please set up and do maximum questions. And you have tomorrow also. So start tomorrow. And like at least you should be completing till 7.55 on Friday. Then you can go a bit slow on Saturdays and Sundays. Okay. But please try to complete the 7.62, and it will be a huge achievement. Now you have 73 questions, right? And out of then only 10 questions will be left. Okay. So we'll discuss those topics, and then in the next class, inshallah, the whole chapter will be completed. So on Monday, we will have the last class on equilibrium. Now we are left with chapters. Well, major chapter is hydrocarbon, right? Major chapter is hydrocarbon. Then we have S and P block chapter. So S block I will complete in 2 hours. That means in one class. P block I will be completing also in almost 2 hours. Okay. So in that, what you have to do, you just have to listen and don't write notes. I will be sending you the notes in PDF. I hope you know that most of the portions from S block and P block has already been eliminated. And the portions which are remaining in S and P block, they are the portions that is already present in the chapter number 3 that we have learned, periodic properties, the general trends. Okay. So hydrocarbons also will not take much time because we have been doing organic chemistry, the basic concepts and techniques. So most of the things I will be borrowing from them. The concepts will be borrowed from the previous chapter of organic chemistry, and we will be applying that on alkane, alkyne, and aromatic benzenes and arenes. Okay. So I hope for this batch also, I will be completing the syllabus at least on the first or second week of February. It will be completed, inshallah, because I think next Monday will only be, next Monday I will be completing thermodynamics. Yeah, surely, inshallah, I hope that, may Allah help me in that. I will be completing that on the second week of Feb. Ab bataiye aap log, when should we start class 12th? Yes guys, tell me.
Sir, after term 2 exams.
Yes,
अरे
sir.
टर्म 2 के तो बाद ही होगा, पहले 12th में जाइएगा तभी तो 12th का पढ़िएगा. तो 12th तो आपका टर्म 2 होगा कम. अरे आफ्टर आवर एग्जाम्स, अरे ऑब्वियसली आफ्टर आवर एग्जाम्स. सो March, how many of you are okay with March first week?
So we are okay with that. We will be just sitting at home.
Yes, Mariam.
Yes, sir.
Yes, end of March कौन बोल रहा है? First week of March I am saying. Umar Abdullah. Reba, what about you?
It's okay.
When is your when are your exams ending?
March 3, I think.
3rd March, na?
Yes, sir.
3rd March. Okay, fine. Okay. So see, we will be starting our batches from first or second week of March. Then another batch will be starting on the 3rd week of March. Then one more batch will start on the 4th week of March. Okay, because we will not be starting all the batches at the same time. Because as you can see, Umar is having, our exams will be conducted in the March start. Okay, so some students, they will have exams on the month of March. Some will end on the some will end on the month of February. So we will be starting accordingly. So we can start on the first week of March also. I will convey this to
Sir, I think we will have our term 2 exams in March.
Term 2 exams in March.
Yes, I think so, sir. Most of the teachers were saying it will be in March instead of February.
You are in which school?
IIS.
Sir, we are not sure. They're just saying. Nothing is confirmed yet.
IIS, that means the Indian International School, na?
Yes, sir.
ये रीबा आप अलालिया तो नहीं है ना? This is not अलालिया. No ना? And रीबा, you are in अलालिया ना?
Yes, sir.
हाँ, ये अलालिया में है और ये हमको फर्स्ट क्लास से बोल रही हैं कि हम इंडियन
Sir, I've always said Alalia.
नेशनल स्कूल में है. I don't know why. Okay,
Sir, I've
fine.
always said Alalia.
Sorry?
I've always said Alalia.
No, IIS
Yes,
पूछते थे हम. IIS पूछते थे. I had only one student from Alalia. I think I don't remember her name.
It was me, sir.
No. Even Umar is also in Alalia, I think. Abhinav is not in Alalia, but Umar is in Alalia. Not Umar Abdullah, but no. Muhammad Umar, I guess, because he was only saying February 20. Okay, fine. So we will be in touch. ना और तो है अभी 2 week तो है कम से कम आप लोगों के साथ, and then we can discuss.